been a ham for a lot of years. I think I got my novice license in 1969. I was a ninth grader in school, upgraded to general. I was very fortunate in that I went to a high school that had an electronics class. This is in Nashville. There were 3 schools in Nashville that taught electronics. 2 of them taught it what I called tube jerking. They taught you how to change tubes in a TV set back then. The school that I went to, I was very fortunate, it was taught by a retired Navy electronics instructor. We started with Ohm's law, got into capacitors, inductors, and then transistors and P and N junctions, and by the time I was a junior in high school, I had enough knowledge to be dangerous, and was able to pass my general and also my second class radio telephone license. I was real fortunate to go to work in a TV shop after school. There were 2 partners in that TV shop. One of them was, he taught, again, troubleshooting as a Navy instructor, electronics instructor. He taught me how to take that gobbledygook that I'd learned in school and turned into troubleshooting skills. So by the time I graduated from high school, I felt real fortunate to have been exposed to those 2 people, and it's really helped me probably as much as anything all my life. Wasn't too long after that I decided to get into repeaters, so everything was downhill after that. I'm sure there's going to be several burning questions that I hope to answer for you this time. You probably haven't heard this term in a while. Some of you that are of an age that might remember hearing the term 3494 or 2888 or something like that. We'll talk about that a little more. DCS, does anyone really use that? What's an uncoordinated repeater? Can anyone vote on a repeater? And you don't have to have a party affiliation for that either. What is R2D2? And what are anonymous Kerchunkers? So we'll try to answer those questions for you as we go along here. Very basic. A radio repeater is a combination, very simply, a receiver, a transmitter. It receives a signal and retransmits it. So it can generally extend your distance. You're going to find those either on tall towers, big mountains, or anywhere you can find it to get as much elevation as you can above ground level. I found this picture. This is supposedly the first known amateur radio repeater. It was built in 1954. It was AM, and it was the K6MYK AM repeater in San Jose, California. My first repeater was not quite that early, but if you look at kind of the history of repeaters, I guess it started in about the 60s the best. I was trying to go back and try to determine as much history as I can, how repeaters have evolved over time. Like I said, the first one was AM. We moved into FM repeaters, and I think that was the big boom for them at that time. We started getting solid state repeaters. My first repeater fell into this category. They were licensed by the FCC. The call sign of my first repeater in Nashville was WR4AUX. Sequentially issued call sign, and I thought I could not get a better one, AUX. Not too long after that, they quit licensing them, unfortunately. But I remember when we had to do that, we even had to do height above average terrain, and you had to do that manually. You can't go to some program you can find on Google now. You had to calculate them on radials on a topo map. So I actually enlisted the help of a broadcast engineer to help me do that for my first repeater application. And this would have been 1975, 76 probably, my first repeater. Then we get into repeater linking via the internet. IRLP and Echolink were the pioneers and still operating there. And then in the 2000s, we got into digital repeaters, and we'll spend some time talking about that as well. Mine was WR4AUX. It was on a 2-meter repeater, and it was very, very homebrew because I was cheap and broke. 147.15. There is still a repeater on that frequency, but it's not my original equipment. It was an RCA commercial VHF receiver. Somehow, I don't know how I did it, but built a little crystal control transmitter that worked at about 10 watts. The repeater controller I built on a little breadboard. It had a 555 as a hang timer and had two 567 chips that put together would decode one DTMF tone that I could turn the repeater on and off. Did not have anywhere near the money to be able to have a duplexer. Man, those were exotic back then. So I did have access to a tower that was tall enough I could put two antennas on it. But I was getting decent, so I took some double-cladded PC boards and made a cavity by soldering all that together. It worked, which amazed me actually, but that was my first bandpass cavity. At that time, I was the chief engineer of a commercial FM station, and so I had access to this nice little tower. It wasn't real tall. It was a monopole about 75 feet tall, but height above average terrain. It was fantastic. I looked down on the city of Nashville, so we had pretty doggone good coverage from that on the 147.15 repeater. As you got into, well, I'd say 70s and 80s, a lot of commercial equipment started coming available. How many people have seen a Micor repeater? I would be surprised. Well, I still got one in my basement. You want it too?
No.
Okay. All right. No. But I do have two UHF. Now, what am I thinking of? The next generation. The first attempt at what's called a microprocessor repeater from Motorola, the MSF 5000. I've got two of those if anybody wants them. As I got to Atlanta in 1981, I went to work for Scientific Atlanta. I was in the Satellite Communications Division. And there was a guy in the group I met, and he happened to be the trustee of W4, is it DOC, the Stone Mountain? No, BOC. BOC is Stone Mountain. He was the trustee for WBOC for the repeater, the 76 repeater on Stone Mountain. And I said, hey, what if we put together a UHF repeater for you, donate it to the club, and we'll take care of it and everything? And went, okay, sounds like a good plan. So if anybody remembers pre-Olympics, there was an old fire tower that what you could see on top of Stone Mountain. The visitor center up there was pretty run down, but you had this fire tower. And it had an antenna grid on top of it, and then the repeaters were on different landings all the way up and down that fire tower. Now, it was about 100 degrees in there, even in the middle of winter. But it acted like a chimney. If you opened a door at the bottom and a window at the top, you would get a tornado rushing up through there, and it would keep things cool. I think we were the second UHF repeater in the Atlanta area, only behind the one that was on Sweat Mountain. So the original 444.25 repeater, a group of us put together on Stone Mountain, and we thought we had the cat's meow at that point, good high point, to do that from. For those of you who have not had the opportunity to the ins and outs of a repeater, very basically, it's a receiver and a transmitter, and you've got to have something in the middle, like a controller. It could be as simple as putting a electrolytic capacitor on the line to hang that COR line coming out of the receiver to the PTT line going in the transmitter. But controllers are awfully cheap nowadays. For under $100, you can buy some nice PC board-based controllers, and gives you a lot of extra functions along with it. Now, most people now seem to have access to a duplexer, which I couldn't at the time. And the big savings there is one antenna. The last time, well, we moved that 147.15 repeater because I'd changed jobs. And I had access to a 350-foot tower which sat up on a ridge just north of Nashville. Well, being the chief engineer for the station, I thought, well, you know, I'm thinking repeater. We had a guy that was going to climb the tower, still didn't have enough money for a duplexer. So we climbed the tower. It was a 350-foot guide tower. Had about 3 foot on a face, triangular tower, guide tower. The day of, we were going to install the antennas and hardline, the guy that was going to climb the tower flaked out. So another guy and I said, okay, we'll do it. Being stupid, and don't ever do this, we climbed the tower without a belt, without a hard hat. You climb up the inside of the tower because it had a built-in ladder by doing that. I took the lower antenna at 200 feet, and my friend installed the other antenna, the receive antenna, up about 75 feet above me. All of a sudden, I hear him yelling, "Headache." What do you think that means? He had dropped a pair of pliers down the center of the tower, coming straight at me. I thought, I'm going to die on this tower. Fortunately, the wind caught enough of it about 20 feet above my head, clanked against the side of the tower, and those pliers went outside. That was the last tower I ever climbed. I got smart after that. So this is a basic repeater. Now, a lot of things can get added to them. Additional receivers, typically they're called satellite receivers. They have nothing to do with satellite, but they may be around the system. If you've got that, you probably have a voter, and this answers that voter question. A voter picks the best, it's listening to all those receivers, and it picks the best one that has the best signal to noise or the least noise on the signal and feeds that to the transmitter. And because it's constantly listening, you may hear it switch between receivers. The Gwinnett Amateur Radio Society has got a repeater with, right now we have 4 remote receivers. I know Atlanta Radio Club on the 8.2 machines got at least 1 or 2 remote receivers, and others may as well. It can be kind of fairly common now to have remote receivers. Our problem in GARS is we've got all these great remote receive sites. In fact, they happen to be primarily on county towers. Wonder how that happened. I guess because I handle the radio system for Gwinnett County, we seem to have access to those. So we've got 3 additional receivers right now, paring down from 5 to 3. The lowest one's at 200 feet, one's at 250 feet, and the northernmost one's at 755 feet above ground. Problem is, our transmitter site is not real high. So it's going to be a receiver that hears a lot, but the transmitter itself is not going to get out quite as far. Yes, sir?
Thanks for that information. I never heard of that. I never heard of multiple receivers.
Well, there's 2 ways that you can connect receivers. Like I described, where you have them connected to a voter and they look for the best signal to noise. You can also have simulcast. Now, simulcast in amateur radio is very, very difficult. And typically you might find it used more on multiple transmitter side. For example, the P25 system for Gwinnett County communications, it's a P25 or APCO 25 system. We have 11 sites. Every one of those sites is actually transmitting each one of those 18 channels, but they're phase locked by GPS. And so they all are transmitting the same signal, but because they're locked, the frequency is locked together, you're really only hearing one. It doesn't distort the signal. On the receive side, it's actually voting. All 18 channels, each channel is fed into a receiver, and because this is digital, it's looking for the best bit error rate. So it actually picks the right one. And if I look at statistics on our system, and this is probably true of even amateur radio receivers and repeaters, and I know I can give you a stat on one of the GARS ones now, you're going to be heard by more than one receiver, likely, unless each one of those are fairly low. I know on our county system, I'm hearing an average, or I'm being heard on an average of 2.5 sites for every transmission. I know on our GARS repeater, the 147075 repeater, because 2 of those sites are so high right now, both of them are almost hearing everything. and it does pick out a little bit of difference between that if there's a little bit of a difference in signal to noise ratio. So it's hard not to be full quieting into the repeater. The repeater, even though it's running like 100 watts, doesn't have the coverage, so we have to be very careful that we're not hearing a whole lot more than we can actually transmit. Adding into some additional equipment, voice over IP interfaces. These are the Echolink IRLP interfaces. There are some others out there as well that are popular as well that interface to even some digital repeaters. That's kind of generally frowned on, linking digital and analog repeaters together, because the digital repeaters have a good clean audio signal being digital, and you get so many things that connect that you can hear on an analog signal. Let me give you a good example. How many people participate in Skywarn and connect to one of the linked Skywarn repeaters around the area? Have you done that? What happens when you link a bunch of analog repeaters or FM repeaters together? Depends on how they are configured. You may hear each one of those repeaters, you may hear their courtesy tone, you may hear beeps and boops and everything else in there, and varying audio levels and quality. And if not constantly and properly maintained, you will get so much difference in audio levels, audio signals, everything, that it can make it very hard. If you listen during, when thunderstorms are coming through and you're listening to the Skywarn linked repeaters, it can be very difficult to understand what's going on. And I'll show you an example on digital here, or why we go digital, in a few minutes. Auto patches. Boy, those have gone away, hadn't they? For those who remember that, you know, that was, honey, I'm on my way home. Yeah, okay, I'll pick up a loaf of bread and a gallon of milk. And then we always had the people who called their office and tried to hide the fact that they were doing business on there. Well, I'm going to be a little late and don't know exactly what's going on, but don't say your name and don't say the business. But auto patches have given way to a lot of the linking. We still accomplish a lot of things we want to do now with some of the linking interfaces that we have. So to give you an example of when you do the voting, you'll have receivers, and each one of these receivers might be located at different areas of the county or different parts of the city, and they go into the voter, and the voter says, okay, receiver one, you got the best signal. I'm going to feed you through to the transmitter. And then that is going on almost constantly. The local repeater here is not, you don't have any remote receivers, do you?
We do not.
But you got a good high place to mount it. So
Delay never becomes an issue?
on AM, on FM analog repeaters, no. It can on digital. In fact, there are very, I want to say, I'm not aware that the voting technology or something like it has kind of transcended to the digital repeaters. There may be some of that going on other than just linking repeaters in an area.
What do you use for backhaul from the remote receivers?
It can be, a lot of people are using 220, and they'll just have a 220 simplex link between them, because it's a one-way signal to connect the receiver to the voter. Some will use UHF. Some have even used N-band in the same band, but 220 got very popular for doing linking. Question in the back?
That was my question also. If the receivers are all local in the same tower, I imagine they're wired.
Well, you wouldn't have more than one receiver on the same tower. They're going to be geographically dispersed. But you've got to connect them in, just like the question was there. So you can bring them back over, like I know in GARS, we have a UHF link, just a transmitter and a receiver sends it back from the remote site, and you collect those with a group of receivers on this end, and then the audio and COR signal comes off of that into the voter. Good question.
Does it ever go over the internet?
You can. And what I was about to say that with some of these low-cost links like Ubiquiti has is one of them. For $100, you can have an internet, either a 2.4 or 5.8 gig link between sites, and you can use that as a very simple way. To get internet to the D-Star repeater I'm associated with in Lawrenceville, we couldn't get it at the repeater site. So we've actually got 2 Ubiquiti 5.8 gig radios, goes over an 8.5 mile path from Lawrenceville to Snellville, where we pick up the internet and send it over. And it acts just like an Ethernet bridge. It's like I have a big wire between those 2 sites. But it could be done also using it for FM and analog as well. Any questions so far?
The intertie system in Central Georgia, Jimmy's done an excellent job. It doesn't do the clink, ka-chunk, ka-monk audio levels. And I think he's using.
That is much better.
He's using 70 centimeters to length them.
You know what, some people, that probably, the intertie system, kind of middle Georgia, middle and part of southern Georgia, you have a lot linked together. Now, what a lot of people will do to link from the Skywarn system to their local repeater, they'll just listen to 146.82, the ARC repeater downtown, and have it listen to it and then feed into their local repeater. And that's how so it ends up being kind of a hub site that others can do and use. So that's how some of that goes on. And then I'm so glad to hear that, and I haven't listened to the intertie system, but I know on the linked repeater Skywarn network, kerchunk, beep, boop, boop, and finally somebody goes, so that's what you deal with. Right. Let me switch over and talk about repeater coordination. Another one of those situations where I failed to duck. Back in 2009, a couple of folks and I worked on getting a grant from GEMA to build out D-Star repeaters around the state. We got it. $250,000 grant, and we bought 9 complete repeaters with gateway PCs, racks, duplexers, a lot of stuff. And I thought, oh my goodness, now I've got to coordinate a 2-meter and a UHF and a 1.2 gigahertz repeater pair at 9 sites around the state. So I went to the guy who was the brand new Georgia director for the Southeastern Repeater Association, who is the FCC recognized frequency coordinating agency for amateur radio repeaters. And I said, Ron, can you help me coordinate essentially 27 pairs in 3 bands? He said, I don't know a whole lot about digital. Will you help me? It was kind of hard to ask for help and not offer to give some help if you need it. What I didn't know was he was going to the next meeting of the Southeast Repeater Association to nominate me for vice director for Georgia. I get a call one Saturday afternoon after they'd voted, and they said, congratulations. So I did that for a few years. I stepped down from that about a year and a half ago. But I learned a lot about repeater coordination. How many repeaters do you think there are in Georgia? Take a guess.
Hundreds.
How many hundred?
250. 253.2.
You're a little low. The actual number is a little over 300. I think it's around 350. 350 repeaters, and every frequency pair in the Atlanta metro area, actually I'll expand that, north of Macon is in use and doesn't have enough separation from someone else wanting to use that frequency to be able to coordinate another repeater. Repeater coordination agencies do a wonderful job, and they've built some tools, especially Sarah has built, Sarah has done a lot in doing tools, so I can put in and say, for this particular latitude and longitude, is there a 2-meter pair that will meet the criteria of frequency separation and geographic separation? and it will do that. You don't have to do it by hand anymore. The tools were built to do that, and we put that online for the state coordinators to be able to do that.
So it's just distance, there's no propagation?
The first thing that you look at, there are some rules that says if you are on 2 meters and you are separated by 30 kilohertz, if you're co-channel, meaning you're on the same, you want to put a repeater on the same frequency, you must be 100 miles away. Now, you also then take into account, is one of these sitting on Stone Mountain or Sawney Mountain or a big tall peak somewhere? If it's on Brasstown Bald, it would be different. Then you actually have a propagation program to predict what it would be up to a certain signal strength between two locations. Because the worst possible situation is you get a mobile right in the middle of those two repeaters on the same frequency, keys up, he may key up both repeaters. Now he wants this one, and he talks through it, but everybody over here is hearing him as well. So you separate them by distance, and then you also separate them by the adjacent channel. Now in 2 meters, we have 30 kilohertz separation between channels. We have 15 kilohertz separation, and down in 144, 145, we've got 20 kilohertz. So there's different criteria that's used. UHF, it's a whole lot easier. If you've got 50 miles between two repeaters, you can go co-channel, and it will usually work unless you've got extenuating conditions of a high mountain or something like that. So you calculate adjacent channel, because how wide is an FM repeater? How much bandwidth does it take?
25 kilohertz.
Well, two good answers there. If you really calculate it out, you're doing 5 kilohertz deviation, right? That's plus or minus. If you apply the formula to it, it's 2 times the deviation, peak deviation, and 2 times the highest modulating frequency. So 2 times 5 is 10, right? And then the highest modulating frequency we say for voice is 3 kilohertz. So that's 6. So 10 plus 6 is 16. And if you look at the FCC emission designator for amateur radio for typical FM, it'll say 16F3, I think it is, and then some other digits or other things in there. So 16 kilohertz wide. So now if I've got 2 channels that are 20 kilohertz wide, I'm plus and minus 10, right? But I'm actually, and if I go 20 kilohertz away, I'm going to be over here and I'm going to overlap with that 16 kilohertz wide signal. So you're going to have to separate them a little bit more. So that's the things that go into calculating that. Now, it is strictly voluntary if you coordinate a repeater. You don't have to do it. But why would you want to coordinate a repeater? It's in your best interest because you're going to make sure, you may say, I've listened to this frequency for 2 weeks and I haven't heard a peep on it. Well, nobody may have used that repeater in 2 weeks, or you're down in a hole and it's on the other side of a mountain and you won't hear it. So the only way you're going to know for sure is to go through a coordinating agency, Sarah in this case, who has a database of all of the coordinated and even maintain uncoordinated repeaters. So if you go through that process and coordinate a repeater, then in a sense, you don't own that frequency, but you're protected to the extent that if someone throws up an uncoordinated repeater and interferes with you, and they go, hey, I got just as much right to be on this frequency as anybody else, and it goes to the FCC for mediation, the FCC will look at it and say, you're coordinated, you're uncoordinated. They did their due diligence to make sure they weren't interfering with someone. Sorry, guy, you've got to cease and desist. And that's been proven over and over. So it's in your best interest to coordinate a repeater.
When you were talking about the mobile guy hitting 2 repeaters simultaneously, where does the PL tone come in to keep separation?
Well, that is something that can be used to separate off two repeaters and eliminate some interference. Yeah. If both are doing PL and they're different PLs, you're probably only going to key up one. Now, you might still hear both unless you have squelch on or PL receive, so that you only listen to the carrier that's got the right PL tone. But if they're both transmitting and you open up for one, you're going to hear others as well.
That leads into my other question. Does Sarah also coordinate PLs?
They have a recommendation for each state that this is your recommended tone that you will use here, because you could have one in Dalton, Georgia, and somebody wants to put one in Cleveland, Tennessee. They're only going to be about 50 miles apart. And because they're across state lines, you might think, oh, well, I don't know about that one. But that can help by doing that, and they'd be on different PL tones. You're free to use any PL you want, and most people don't really adhere to that, but they'll use some tone. There was a situation that involved what was the KI4SBA repeater back a few years ago, the D-Star repeater on Sony. It's on 145.200. Now, that's in between the normal FM repeater pairs. Now, I'll talk a little bit more about that, but digital signals are narrower, so it was coordinated there. There is a repeater down on Pine Mountain, down near Columbus, north of Columbus. What am I thinking of? Where the little White House was. Warm Springs. It's on that ridge right there. And he did not have PL on his receiver. He swore up and down that the KI4SBA D-Star repeater was interfering with his because his squelch would open up and he'd hear something. Well, he didn't know what it was, but he was told, if you're going to complain, put PL on it, and then let's see what happens. He refused to do that, but he was told, you've got to accept what you think is interference. It could be anything. It could be somebody kerchunking and keying it up. Every time he heard it open up, he assumed it was the repeater on Sawney Mountain. Didn't know that for sure. So that is almost every repeater. In fact, Sarah says if you're going to coordinate a repeater, you have to put tone receive on it to be properly coordinated.
What are the repercussions for someone that puts up an uncoordinated repeater and the output is on a simplex, designated simplex frequency? There's one near us that we really can't use our backup frequency, 146.46. You get on a high enough spot, you can hear them.
Well, what happened with that, when digital repeaters, and I'm talking D-Star, DMR, and this was before Fusion really hit the market, there weren't any 2-meter frequencies available in populated areas. And again, that in Georgia, that's Macon North. So the Southeastern Repeater Association made some odd split pairs. And they took away, in a sense, kind of created a special band. You used to see a lot of packet repeaters on 145, 01, 03, 05, 07, 09, right? 144 on those. Now, the most popular one, I think, was 145.03, I think, was one of the most popular digipeater frequencies. So what Sarah did is say, okay, I'm going to let repeater outputs for narrowband digital repeaters go on 145, 02, 04, 06, 08. 144, 92, 94, 96, 98, and then 145, 02, 04, 06, and 08. Well, what do you do with the inputs? So what they said is you've got basically from 146.40 to 146.60 is typically simplex, right? That includes like 5.2 is in that area. So what they said is, okay, let's take 4 pairs in 146, 4.2, 4.4, 4.6, and 4.8 and make those the inputs, not outputs, inputs. So those were designated for narrowband digital repeaters, which would qualify as D-Star or DMR. So that's why you're seeing those. And then also 147, 42, 44, 46, 48. But that left you 146, 50 through 60. So would it be possible to use one of those other pairs as what you're calling a backup frequency?
This is not digital, it's an analog repeater.
I know, but you shouldn't have an analog repeater. Well, it can't be coordinated if it is in there.
It's not.
So you're saying this is one you've heard on the air, we don't know
Yeah.
who has it.
Yeah.
It's out off 75, like, if you get up on anything about 1,500 feet, you can hear it.
Yeah, they're running an uncoordinated repeater. They're running outside the designated band plan, and so they kind of do it at risk.
There's
Again.
also somebody that has a crossband from
Mhm.
Gainesville repeater to 446.0.
Mm-hmm. Yep. You'll see some of that around. So that's in there. We spent a lot of time talking about coordination of repeaters, but it is a very important part. If you want to put up a repeater and administer one, the trustee of one, this is something you need to be very careful about. All right. Yes, sir.
It's always been that you could run an uncoordinated repeater.
Yes.
I don't remember early on that being a possibility.
Well, if you go, Sarah has been around in Georgia coordinating repeaters since the 80s. Actually, not true, 70s. Because I got a coordinated pair for that Stone Mountain repeater that would be in 80, 81, 82, somewhere in there.
I was involved in coordinating the 76 repeater back in 62 or something.
Mm-hmm.
And I know we had to go to the FCC and pray.
Well, and that's when repeaters were licensed.
They were licensed.
And you had, the FCC got into that business, but they decided this is too much trouble, we're getting out of it. Since I know at least the 80s, coordinating bodies, at least for Georgia and the Southeast, have existed. I coordinated first, I put up a repeater on Gwinnett Medical Center in Lawrenceville, 444.0, and this is probably the late 80s, and I went through the coordination process. Now, there was another 444.0 in Savannah, but I'm UHF. How far is it between Lawrenceville and Savannah? Quite a distance. More than 100 miles, I'll tell you that. Here's the problem with coordination and the downfall of it. What about band openings? You don't see that so much on UHF, but you do on 2 meters. In the spring, you get a thermal inversion. We have that problem with the GARS repeater. There's one not too far across the line in Alabama on 147.075, and there are some mornings in the spring when you get the right conditions, you'll get that ducting, and we'll hear it full scale in Lawrenceville from Alabama. You can't coordinate for openings, band openings. You coordinate for normal propagation. So, how many days a year do you get a band opening like that on 2 meters? A handful, maybe. So that's the problem. All right, repeaters go digital. This really got me interested again in repeaters because I hadn't done anything for a while. And so when I started learning there were digital repeaters, this is neat stuff. There's a few things to remember with a digital repeater. Digital voice is usually very spectrally efficient. Where we're talking about a FM signal is 16 kilohertz wide. It takes up that much space in a band. If you look at 2 or 3 of the modes, D-Star and NXDN, its occupied bandwidth compared to 16 is 6.25. About at least less than half. DMR, I think it's 7.6. So it's less than half. So you will see that typically that digital voice is a way to add more repeaters in the same space, in the same bands. Of course, the bandwidth depends on the data rate and the modulation type. But the primary ones that have emerged, the 2 primary ones are D-Star and DMR. Those are from 6.25 to 7.6 kilohertz with a data rate of either 4,800 or 9,600 within those. So that's what they occupy. I'm going to show you a couple of things about audio quality, but it's generally static free until you get a very weak signal. So like your FM signal, as you start getting away from the repeater, you start getting noisy, you start getting some hiss, some static, everything in there until you're dropping out of the squelch and you can't be heard anymore, and your signal is very weak at that point. A digital signal is going to hold, be the same, be the same, be the same, until you get out to that very weak area, and it drops off. There will be a little bit of no man's land in there between where it's just starting to drop off, that you're starting to get bits of it. It can't fully reconstruct the digital signal back to analog where you can hear it. And that's typically what we call R2D2, because it sounds like the Star Wars robot. You hear that more on D-Star than you do on DMR, and when we get to those, I'll tell you why that is the case. Let me see if you can hear this. It took me a while to find this, but this is why we do digital voice. Now, if I can get it on. Hang on just a minute. Let me see if I can get that. Okay. See if you can hear this.
Hi there, Mr. Kimball. I'm glad you're here. I wanted to ask you.
Yeah, be with you in a moment. Agent Kimball calling headquarters. Agent Kimball calling headquarters. Coming over loud and clear. Not clear, but loud. My present location is, which farm is this, Mr. Douglas? Oh, boy. The old boy farm. Any instructions? Yeah, your transmission understood. Over and out. Yeah, the chief installed these in all the county agents' vehicles so we could keep his Menley's beck and call. Which reminds me, did I call Beck today? Oops. Time to check in again. Say, do you see a microphone around here? Oh, you had it. Well, you better watch it. This is official equipment. Agent Kimball calling headquarters. I'm presently at, where am I? Oh, for the Ophir place. Mr. Kimball, over and out. Modern communication is a wonderful thing. Yeah, back in the old days, if I wanted to get in touch with the chief, I'd have to stop, get out, light a fire, set up a smoke signal. Yes, chief? Right away. Yeah, I guess I'll have to skip lunch. Gotta get back to headquarters. There's an emergency.
So that's an exaggeration of why we go digital, so we can get clearer voice. But here's what I was saying about signals. If you look at analog modulation, a single sideband signal is about 2.7 kilohertz wide. An AM signal is double that, double sideband, 6 kilohertz. Our standard 5 kilohertz FM all over is that. Now, if you look at, this is a little misleading in that for narrowband, like D-Star, NXDN, it's 6.25. For DMR, it's 7.6. Now, you're going to hear some people saying DMR doesn't quite take it to this extent, that it's two signals, it's TDMA, time division multiplex. So you actually have two different conversations on one carrier. You get a slice of this one, then a slice of this one, then a slice of number one, a slice of number two. So they're actually fitting two in that space, and what we normally say is they'll fit within a 12.5 kilohertz channel, which is still half of what a standard FM is. In reality, that's still only about 7.6 kilohertz wide for a TDMA signal. That's DMR. P25 is a little wider than that, but you don't really see any P25. That's commercial. All right, and what you're doing, you're transmitting data. If you listen to a digital repeater with an FM radio, what's it going to sound like? It's going to be kind of a hiss and buzz, just kind of a zzz, 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 zzz. You won't decode it, but that's what you're receiving if you ever hear that. For example, if you listen to the W4CBA repeater tuned to 145.20 and listen on an FM receiver, you're going to hear that buzzing, hissing sound. Here's what I was talking about with the digital signal. As I'm going out, signal strength is going down. So I go out, I still have 100% clarity all the way out to this point here, and then I'm in R2 land, and it drops out. Now, if I had an analog repeater and signal, as I start lowering my signal strength received at the repeater, I start to get more and more static, more and more hiss, and it becomes very noisy. And so at this point down here, where it's almost an unreadable signal, is the land where the digital signal drops off from full, no breakup, no interruption in the signal at all. So some people will ask, and I've been asked this question many times, which gets out further, a digital or an analog signal? And I have a definite answer on that. It depends. It depends on a lot of factors. A digital signal, as you get out in this area out in here, you might have fading, picket fencing on the signal, and that makes it harder to reconstruct that signal back to analog. It may be that I can copy down in this area where I'm starting to hit R2D2 up here. So I'm not going to say one works better than the other. One's going to get more range than the other. Depending on the conditions, you generally will have this situation going on repeaters. Does that make sense? Yes, sir.
What about, I guess I'm hard of hearing, so I have enough trouble even on analog radios, but it seems like some of the digital stuff that I hear, I have a hard time figuring out what the words are. I mean, I can tell the person is talking, but I'm missing a bunch of words.
Right. When someone first starts listening to a digital signal, whether it be a DMR, D-Star, Fusion, whatever, some people will say, I'm having trouble kind of hearing it. Even though I don't have any static in it at all,
Right.
It may be kind of hard to understand. Remember, this is low bit rate voice. It's not high fidelity. It's not CD quality voice by any means. But you do take the static and interference component out of it. And your brain actually trains a little bit the more you listen to it. I do nets. I'll be a net control station for both our club net on Monday nights, which I got to miss tonight. And then on Sunday nights, we have on D-Star a Southeast D-Star weather net, and we'll have 50 plus repeaters and a bunch of hotspots linked from Texas through the Carolinas. And we'll have people checking in on that, and I'll do net control on it. And my ear has become a little better tuned to listening to that digital voice, and now FM sounds weird to me. So, there's a little bit of brain training. It is a little different. I actually call it, the best way I've been able to describe it, it's kind of a metallic sound. I don't know whether that makes sense. But it's you don't have a lot of the inflection that you'd hear in just regular analog voice. But once your ear gets trained a little bit to listen to it, gosh, you won't want to listen to an FM signal anymore with noise on it. DMR, digital mobile radio. It was a radio standard that was developed by the European Telecommunications Organization, ETSI, in Europe for digital radio. In North America, we had P25 or APCO 25. And so the Europeans had to come up with their own digital standard. There's a couple of levels of it. One is called Tier 1, and it's more like FRS or GMRS, but it is digital. Tier 2 is what we typically see in conventional radio systems, repeaters single repeaters, and in the U.S. it was developed as 2-slot TDMA. So what I said before, you've got two different conversations going on the same RF carrier, and you only listen to one of those. Your radio picks it out. Tier 3 has not, it's actually used commercially. Got to remember, this became a standard for dispatch type systems in like public safety. You will see like some hospitals and small organizations, cities that use DMR. Jackson County, for example, instead of going with a typically more expensive P25 system, they did DMR. And it's a trunked system among several sites. Motorola, like they normally do. Anybody from Motorola in here? Even if you did, I was still going to say what I'm going to say. Motorola always adds some proprietary technology on top of every standard. That's Motorola. They've done that for decades. Right, Mike? So they added some proprietary networking on top of the DMR protocol, and that became an offering for lower cost systems in smaller municipalities that couldn't afford a big Motorola P25 system, which it runs at about $1 million a site. So you can do these for quite a bit less. Now, DMR made its way over into amateur radio. So initially you had an organization called DMR MARC, which was the Motorola Amateur Radio Club, MARC. And most of these guys worked for Motorola shops, Motorola dealers, and they were the early guys in DMR. And they used $500 plus Motorola radios on DMR. Well, the Chinese got involved. And so they started offering less expensive radios for DMR. The first system to do it was Connect Systems. And they offered a DMR radio, fully compatible, for about $200. And that really caught on, and DMR began to grow very rapidly with that. Since then, more Chinese companies have come in. Tytera, you see these TYT 380 and 390 radios for around $100. They're almost down with the Baofangs now in price. So that has done a lot to spur the growth in DMR. Some differences that you have to keep in mind: every one of these technologies has its pros and cons. It is easy to link repeaters together via the internet on DMR, and the Motorola flavor of that typically calls Moto Turbo, but I think the industry didn't want to give Motorola a lot of credit for it, so they said they just call it DMR. It's kind of how it's known now. They're linked via the internet. They don't link to other repeaters directly. They link through a device called a C-bridge. And that C-bridge is where the actual intelligence for a repeater and how it can link is located. And you have talk groups. So I could have a talk group that I call the Atlanta Metro Talk Group. I could have the Southeast. I could have a Georgia. I could have a worldwide talk group. And what I have to do is command that repeater to open up that talk group. So an advantage or disadvantage, as you may say, the talk groups are defined by the repeater administrator. So you may not have access to all of the talk groups that you want, but most repeater owners that have a DMR repeater say, okay, yeah, we'll add that if you're interested in it. So it's not really a big limitation. DMR has grown. It hasn't been in amateur radio as long as D-Star, which we'll talk about, so it has the second largest user base and number of repeaters worldwide. It continues to grow. So, and another thing has come into play. The Europeans have kind of developed to get away from the DMR MARC people controlling as much, and in Europe they have Brandmeister, and Brandmeister kind of opened it up a lot more to different talk groups and reflectors and things like that. So that worked out very well. DMR is a very good technology. How many have seen a DMR radio? I didn't leave home without some samples. All right, this is a DMR radio. I'll let you pass that around. Please make sure it gets back to me in the end. That one is one of the Connect systems. Boy, I almost hit the key the other day for one of the TYT 380s, or 390s actually, because it was right at $100. I think it was $91 on Amazon. It was probably during Prime days. And I was just short of hitting the button. I went, no, wait a minute, I've already got 2 radios. Do I need a third one?
Someone showed me a bow thing that was a DMR the other day.
Yeah, I'm not real excited about that one. The TYTs are good. They've got a color display on them. Very nice radio, and there's a lot of code plugs out there, which you talk in code plugs. This is a carryover from the older Motorola radio days, and a code plug is really just like your memory file. It's all the parameters you need to program the different talk groups and repeaters in there. So you can find if somebody gets a brand new TYT 390 and they need a code plug for Atlanta, somebody's got one out there, and you can just use the software and drop it in your radio and be going. So DMR is good.
Can I add one thing to your answer to him about the loudness? So the unit of measure of sound pressure is the Pascal. And so when a digital signal is converted back to the speaker, like in a phone or a radio, and I actually worked for you when I learned this, we first turned up GSM system. You couldn't hear very good. It was clear, but there was no volume control. So when a digital signal is analog converted back to actual speaker driver, it's not as loud. So Bill's not as hard of hearing as he might think.
Yeah. I know there's still, I still will go back to, because I experienced it, you do have to let your ear and your brain kind of train a little bit to them. And that will make a big difference as well. DMR, I like it. I use it. I've actually helped put a couple of them on the air. There used to be, well, I think there's one on Sony now, isn't there?
Right.
So you've got one there. You've got one over in Hall County on, what's that mountain over there? Walker Mountain. There's one over there. There's one over in Snellville, between, going out toward Athens. Snellville, I think I said. There used to be one downtown, and they got kicked off the building they were on. What was the old Bell South and the AT&T building downtown? They sold that building. So they lost that site, but I understand there's one going on the Bank of America Tower with the ARC repeater down there pretty soon. So pretty good coverage around the Atlanta area, but in the southeast, you won't see quite the density of DMR repeaters around that you have, say, up in the northeast and out in California. Yaesu System Fusion. Choose my words carefully. Yes, sir.
Repeaters, analog repeaters, very seldom used. Is all this digital repeater, are they more active?
What makes them more active? The answer is yes. And what makes them more active is they're linking to other areas. Like, for example, if you have your local DMR repeater that monitors the Southeast talk group, you're going to listen to conversations all over the Southeast, or you can talk to people over that. On D-Star, they link to reflectors, which are like conference bridges. We'll talk about those. Most of the Georgia D-Star repeaters link to 30 Bravo, we call it, reflector 30 Bravo, and that's all the Georgia repeaters, and so you have more activity with that. Or you can, if you want to get on and always find someone, go to reflector 30C, 30 Charlie, or reflector 1 Charlie. Those are worldwide. You key up on one of those connected to one of those reflectors, and you never know who you're going to talk to.
One other question.
Yeah.
You have a real emergency situation come up, and for some reason the internet is off. What good is digital?
You still have a local repeater that covers the area. Get this question a lot with ARES organizations. They'll go, well, you can't depend on the internet during bad weather, emergency conditions. I'll counter that with 2 examples, but worst case, you drop back to a local repeater coverage. And most emergencies are local in nature. So I'm still, if you've got a repeater, which you do, on Sawney Mountain, you still have the coverage area of that repeater if it were to be used in an emergency, in Aries or, Skywarn or whatever. You could not talk to California or Australia at the time, but to counter those arguments, though, people say the internet always goes down. Was it Irma that we got the remnants of coming up from Florida? Frank is the state section emergency coordinator. Where did he go when you need him to verify something? During Irma, on Sunday afternoon before, we were just getting the edges of the storm coming up from Florida, and it was just getting into South Georgia, and HF on that day was dead. You couldn't talk across the street. Just one of those days that the HF bands were dead. We used D-Star because we had a state network of repeaters, and a lot of the hospitals then connected in through their local D-Star repeater. We had some intermittent, we might lose a repeater in Tifton for a few hours and it might come back because the internet was restored. But we never lost the whole network. And so while the HF band was dead and we weren't using linked repeaters on FM, we used D-Star in this example and passed hundreds of messages from hospitals around the state. Now, is that appropriate for every situation? No. But it's another tool in the toolbox. Normally, the next day, HF was good. So they could use HF. We still had both HF and a linked digital repeater network as well to work with. Yaesu System Fuse, to answer your question?
Yes, and I was surprised when I saw that hurricane that went through Puerto Rico, and the ARRL asked for volunteers, but they said, we only want volunteers that have D-Star capability.
Well, actually, that's true, but a lot of what they wanted was someone who could do HF WinLink, and a lot of people said they could, and they got down there and they didn't know how to do it. We were fortunate; we had someone from down in Fayette County who participated and went down there, and he was an experienced HF WinLink operator, and he passed traffic for 3 weeks that he was down there. But yeah, there is a D-Star repeater in Puerto Rico. I'm sure they have FM repeaters as well. Getting out of Puerto Rico was primarily a case of if you could get out on HF, that was the primary way to do it. Fusion. It's a good technology. When it's one of two that were developed specifically for amateur radio, where DMR was developed for commercial and brought into amateur radio. Fusion was one of them that was specifically for amateur radio. So one of the advantages of that is your call sign is actually transmitted. In DMR, a radio ID is transmitted, and you have to have a lookup in your radio to translate that to a call sign to see it, because you don't have call signs for individual radios in commercial. So Fusion came about. Now Yaesu, and this is, I'm trying to think of the year that it started. They announced, at one point, Yaesu was owned by Motorola for a short period of time. They actually wanted to get their commercial customers, the Vertex line, which is the commercial line under Yaesu. And so they said, we're going to build a digital radio. We're going to do a digital standard that is not D-Star. Something about Japanese culture, it's like, I cannot do what you're doing or I'll fall on my sword. I don't know what it is about the Japanese radio manufacturers, but that's their culture. So they said, we're not going to do D-Star, which was already pretty popular. And DMR was just in its infancy. And so they said, we're going to do a digital standard. We're going to do 2-slot TDMA, but we're not telling you much more than that. And this was leading into Dayton. So going into Dayton, the DMR folks said, oh, I know what they're going to do. They're going to do DMR, and we're going to love these guys, and there's going to be cheaper radios. This is before some of the Chinese DMR radios came about. And then they put out a white paper on it, and you can still find that out there, and it says they're going to do 2-slot TDMA. Well, then, between December and Dayton in April, Motorola spun off Yaesu back into its own company. They struggled because they didn't know what resources they had, again, available to them.
How long ago did Motorola own?
I'm going to say about 2012, 13, somewhere in that frame.
Wow.
And they spun them back off. And so they were scrambling. What are we going to do? So they totally regrouped and came out with a separate standard. It's not compatible with DMR. It's not compatible with D-Star. It's not compatible with anything else. It's a good technology. What they did, they had several modes. There was simultaneous voice and data, and you can see kind of how much space it occupies. So you can do voice and data. You can do wideband voice, wideband data, or narrowband. If you do narrowband, the audio quality suffers a little bit because you're going to a narrower bandwidth. And then they said, we're going to do repeater linking. We're going to use our Wires platform. We're going to call it Wires X. So they did that. They were very late in getting it out. In the meantime, these other two modes were growing by leaps and bounds. They finally came out with it. You could not link repeaters like the other two modes could do. But what Yaesu did, that was a fairly smart move. They said, we're going to seed the market with digital capable repeaters. And so they offered this $500 repeater program. You could buy a 25-watt repeater that would do FM, or it would do fusion. And they sold about 2,000 of them. Where their mistake was, they didn't have anything to support those. And so most people bought them to replace their 1980s Mycore repeater, and they never put a digital signal through them. Most of those still to this date have not heard a digital signal through them, even though they're capable of that. Then they figured out, well, we can't make this work with repeater linking with this current architecture. So they said, all of you who bought the $500 repeaters, I'm sorry, but they're not going to do linking. So we're going to sell you a new one, and you can trade your old one in, but it's still going to cost you more money. And they still don't have that exactly worked out yet. So it's unfortunate. It's a good technology, but Yaesu, in their marketing and introduction to the market, kind of left something on the table with that. It's a shame. D-Star. I'll give my disclaimer right up front. I do all of the digital modes, but D-Star has been my favorite. Mainly because I've been very active in Aries, and you can do voice and data. We got that grant from GEMA to build out a lot of repeaters around the state, so it's been the one that I'm most familiar with. It's an open standard. It was developed by the Japan Amateur Radio League, which is kind of like the ARRL and the FCC rolled into one in Japan, and it was specifically designed for amateur radio. It's very narrow. It was first adopted by ICOM. Actually, Kenwood made a radio early on, but they never really marketed it. Now Kenwood has, this is an old slide, Kenwood has introduced the TMD 74A as a D-Star radio. It's good radio. D-Star has the largest digital user base and number of repeaters worldwide. You can do voice and data on a single carrier. It's the networking, to me, is a lot more flexible than with DMR because it's up to the user where I send my signal. If I want to link to a repeater in California, I can do it from this radio, and I don't have to depend on the system administrator to do it. So that works out very well. D-Star radios. Pass around 3 flavors of it. I'm actually going to get it back. I'm amazed. The red one is an ICOM. The blue is an ICOM. It's a later version of it. And then the Kenwood is that D74. all of the D-Star radios do both FM and the digital mode as well. So one of the things I really like about that, in D-Star, the second generation of radios, which you have now with the ID51A, the 5100 mobile, the 31, all of those, the 4100 mobile, they implemented what people would say for DMR and for D-Star, it's too difficult to program a radio. Well, honestly, it's difficult to program any radio, but what ICOM did, which was a very good move, they said, we're going to make it a lot easier. And they introduced something what's called DR mode. DR mode is you've got two things in the radio that really make it nice. Number one, you can add an SD card to it, so you can store a bunch of repeater lists on it. It also has built-in GPS, which the Yaesu has that. So combine that with, I can say, I know where I am, the radio knows where I am, and if I've got a database stored in my radio that is geocoded, and I can say, the coming repeater is at this location, I calculate where I am, and I can say, give me the nearest repeater. And it pops right up. I don't have to program anything. And that list can be updated, pull down a file off the internet, works out very well. So when Brian added the 2-meter module back on W4CBA, it was easy to just download a new file, import that into the radio, and suddenly I've updated all my repeater database.
Does the Kenwood do that also?
The Kenwood does it as well. The ICOM, the 51As, 5100, 4100s, you can do nearest FM repeater as well as nearest D-Star repeater. The Kenwood will only, right now with the firmware that's in it, only do nearest D-Star repeater. Still a nice feature, very nice feature. A lot going on with D-Star. It's probably, well, like I said earlier, it probably has the largest user base and it continues to grow. We've got over 30 repeaters in Georgia of the 300. I know of one just went on with a VHF and UHF pair in Jersey, which is out near Monroe. There's a new one going on, a new 2-meter going on. In fact, I just programmed the gateway for it yesterday. That's going on in Sandersville. So, I mean, they're adding all over. If you look at northwest Georgia, north central Georgia, D-Star coverage and the metro Atlanta area is excellent. And then you've got repeaters going down. There's only one stretch of I-75 going to Florida that is not covered, right around Cordele. But you've got them in Macon, Tifton, Valdosta. They're in Albany, Columbus, Pine Mountain, LaGrange, and then going out to the east toward Augusta. There's 2 out in Augusta area. So it's an interesting mode. I like it a lot. And one of the things that made D-Star very popular, they would have fallen, I think, to the same shortcoming as Yaesu if they had not done this. Yaesu, even though they say it's an open standard, they haven't released the protocol. And so that from the very start, it was an open standard for D-Star, and so you had a bunch of third-party products being developed. Have you heard of DV dongles, DV access point, hotspots, Zoom spot, you name it. These are all little hotspots that I can set on my table, connect to the internet, and then I can talk from my radio to that and then get onto the D-Star network. Now, most of those now are multi-mode, so I can also do DMR on them. So that's really nice. But that's kind of what D-Star has done for digital, and you'll see it's, especially in Georgia and the metro Atlanta area, D-Star is probably the most popular of all of them, but DMR has got some good repeaters around as well. So that's kind of it. All the questions.
Well, what's the difference? These both stay the same model though,
ICOM,
The third version of the same radio.
ICOM did some interesting things with their ID51, which both of those are ID51s. They came out with a 51. It didn't do nearest repeater. So then they came out with the 51A, which was really just a firmware change, but they wouldn't go back and upgrade the old ones. So you had to buy a 51A. I think that was bad for amateur radio, but they did it. Then there's the 51A Anniversary Edition, which just had different faceplates. Then they had the 51A Plus, which added some new features. And then there's the 51A Plus 2, which that blue face one is a Plus 2. And what they added with it is two features which are not real exciting. They call it kind of simulates a dongle or a DVAP, but it doesn't do it real well. So,
But
if
they all have GPS in them.
yes, they do. Mm-hmm.
One of them says GPS, the other doesn't.
Yeah, they all have GPS. The 51A and on after that do nearest repeater. Yes, sir.
Are any of the Chinese companies going to start pulling out some low-end price-wise?
One of the things that is keeping the Chinese from doing it is the vocoder chip. Now, it's proprietary to a company called VLSI. VLSI, is that right? I think. And so that's about a $25 chip. Now, you could come up with a software vocoder, which the vocoder translates analog to digital and digital to analog within the radio. You could do it in software. It would take a lot more processing power, so most of the manufacturers decided, why don't we just get this vocoder chip for $25 and put it in a radio? They're buying in 100,000. In fact, in ICOM, they bought the license, so they embedded it in the silicon in the radio. Chinese can't overcome that because that is a proprietary voice coding and decoding technique. Now, it wouldn't surprise me if the Chinese copy everything else and put it on the market, so it might happen someday, but so far they haven't. The company Connect Systems was going to offer a dual DMR and D-Star radio. They said that for the last 4 years, and they haven't come out with it yet. They make a good DMR radio, but they haven't come out with a D-Star radio. Kenwood made an excellent first radio in D-Star. It has an awful lot of the features. It has the DR mode to do nearest repeater, although it will only do nearest D-Star repeater, not nearest FM. It's a firmware upgrade to be able to do it. The other thing that Kenwood did not do in their radio was their data implementation, what we call DPRS. They didn't quite get that right. Again, both these things are firmware upgrades, and several of us try to have a lot of communications with Kenwood about that. Back when we had Phil and the Kenwood office located over in Johns Creek, it was a little easier. They've moved that to Texas now. But we still, at all the Hamfest, we talk to all the Kenwood folks and the ICOM folks and give them our pluses and minuses of all the radios. Any other questions? Right.
I've seen around the country there's several groups that have digital nets where they're linking D-Star and DMR reflectors. How are they accomplishing that?
Well, they're doing that. There's two ways you can do it. One, you can decode it down to the analog level and bridge them. That's a crude and low quality way to do that. Some of them have been able, in what you're seeing the most of them doing is they actually translate one digital standard to another. And even though they both use the VLSI AMBI, usually it's the AMBI +2 chip now in them as a voice coder, while the voice coding technique is the same, what it translates to it in protocol is different. So, where the header is, where the data is, where this and that is different. So they actually take it down to the bit level and then translate it. So that's how they're doing it. Now, they are different voice coding data rates. So you can hear a little bit of artifacts and some other stuff in there, but it's kind of neat that you can do that. So people have been linking DMR and D-Star. Fusion was the easiest to do, so you see quite a bit of DMR and Fusion linking out there. But I'll give you a couple of websites. For DMR, Brandmeister, BRANDMEISTER, and then also DMR Mark. But if you just Google DMR, you're going to find quite a bit of information out there. For D-Star, a good friend of mine does a real good site, dstarinfo.com, and that's where you can also pull down new repeater directory files to load into your radio, so it makes it real easy to do that.
John, on the point of the D-Star hotspot, whatever the right name is, does that have to be paired to an individual radio's ID? I mean, I'm thinking maybe at a field day, if we set one up, could anybody with a D-Star come in and hit that?
Yes. Yeah, good question. They're not repeating, so it doesn't repeat to the other station, but what it does, it connects your radio into the internet, to the D-Star network, and then comes back out and retransmits on a frequency. So it's like in one way, it's like a simplex repeater, but it's not really a full repeater per se. But yes, you set up a hotspot at a location, and you could have all the users there wanting to get on. Now, you couldn't get on different reflectors. You'd all get on 30 Charlie or something like that to talk. But yeah, that works. That works well.
So has Aries made D-Star their default communication method?
Aries really hasn't said that it is, but here's what we did. If you look at doing digital data, and from that I'm talking about WinLink, I'm talking about FLDigi or the NBeams package, and DRATS is a data over D-Star data protocol. And Frank, since he's the section emergency coordinator and came back in the room, I'll catch him off guard.
Wait a minute. I'm president of the Jasper Radio Club, that emergency stuff.
Oh, you don't know anything about that? This is an easy question.
I could guess it.
What we said was, and I guess I kind of had a role in this, there are dozens of digital modes. If I want to send a data file between point A and point B, from the hospital to the EOC in a county, whatever, I can do it packet, I can do it keyboard to keyboard packet, I can do it this way, I can do that way. In fact, when I was the emergency coordinator for Gwinnett County, I intentionally created chaos one meeting. I said, bring your favorite digital mode and we're going to talk to each other. Frank's heard me tell this story a bunch of times. What we did was we said, okay, we're going to divide up into 4 groups. And I want Group A is going to send messages to Group B to C, C to D, etc. How many messages got through? 0. Because, I can only do keyboard to keyboard packet. I can only do DRATS. I can only do FLDigi. So what we said is we need to standardize. So we started this in Gwinnett areas, and I think it kind of got migrated to the state as well. Say, let's focus on 2 or 3 modes that we can practice, we can learn, we can try to implement, so that we don't get caught in that situation again where 2 people can't talk to each other. Now, we still have 3. So the 3 that we chose were WinLink, and WinLink can be done over HF, it can be done over VHF, it can be done over mesh nodes, it can be done packet, a lot of different ways to do it, but it's a package of protocols to be able to, it's basically radio email is the primary thing. You can send files and attachments and things like that. We also said FLDigi, the NBeams package. It has its advantages and disadvantages. It's easy to do. You can do acoustic coupling to your radio and get it going in 5 minutes. And then we said, okay, for the ones that are on a digital mode, right now we have the most D-Star repeaters in Georgia. So why don't we do DRATS as the protocol for that? You can also do DRATS over the internet without a D-Star radio. But if you're doing it over radio, it does require a D-Star radio. And we can link, so we can send messages from Valdosta to Dalton if we needed to do that. So while the ARRL in Georgia didn't, or Aries in Georgia didn't say D-Star is our primary digital mode, because there's more D-Star repeaters, it gets more widely used. Was that a fair way to say that, Frank?
Well, it's not 100% accurate. I went to John and asked him, what are y'all using, what words? He told me, so I pushed Tom Ollie in, he was the ASEC for digital. Tom, make this a standard for the state, and that's how that happened, because it worked. But yes, the rest of it's 100%.
Yeah. Did that answer your question?
Yeah, is there something about D-Star being on what public
Yeah. At one point, when Georgia Public Broadcasting was converting their TV stations from analog to digital television, they actually installed some antennas for amateur radio on those towers. There's 9 towers across the state. Those are generally 600-foot towers, and you've got 2 antennas for amateur radio use on those. And we were originally, we tried to figure out what are we going to do with that, because it was a gift. The guy that was director of engineering for GPB was a ham, and he believed that, boy, this is a resource that could really help with emergency communications across the state. We talked about putting packet repeaters up. We talked about doing a lot of stuff, and we said, why don't we do this, because it'll do voice and data. So on several of the towers, we actually put D-Star repeaters, and that was part of our grant that we got from GEMA. Boy, that was a wild ride. That grant came out of a year's worth of work, a presentation to GEMA about a year before, and then on the week, 5 days before the end of the fiscal year for Georgia, they said, okay, I got you some money. Here's the catch. We got to have POs out the door by Friday, and this is Monday at 5 o'clock. And here's the second catch. We don't have time to put things out to bid, so it's got to be on the GSA contract. Now, fortunately, ICOM had all their radios on the GSA schedule. Could get that. I had those by 9 o'clock that night. Since I was called in Seattle, I had that secured. The next day, we talked about duplexers, power supplies, racks. We've got these 7-foot Dell racks. They're probably $1,500 a piece, but because we could get them real easy that day, we got those. They weigh a ton, too. Hauling it up at a site up at Jasper, it was fun. So that was kind of the story on that.
So they're not on every one, but they're on.
No. They're on Stone Mountain, on the Channel 8 tower up there. They're on the tower down in Pembroke, which is between Statesboro. It's about 50 miles inland from Savannah. Even though there's a Savannah repeater on, there's also a Pembroke, so it kind of covers the coast as well. We've got it on the GPB tower over on Pine Mountain over at Warm Springs. And we were going to put it on the one up at Chatsworth, up on Fort Mountain, but it didn't work out for that. One of the problems we had there, some of these sites, we could not get internet to them. And so, I mean, you couldn't even get DSL or cable because they're so remotely located. And we could not get on their fiber DS3 network that was feeding the TV signal of those sites.
So out of 9, you got 4.
Yeah.
But the rest of the towers have antennas.
They have antennas on them. Some of them didn't get installed correctly, unfortunately. They allocated about $30,000 for each one of these sites because I got them to step up to, we have a commercial Sinclair wideband VHF antenna, beautiful antenna. And then we have at that time it was a Diamond X6000 tri-band antenna because it'd do VHF, UHF, and 1.2. And that's what we connected to the D-Star repeaters. Generally, they're at 550 to 600 feet on those towers fed with 1 5/8 hardline.
There is an advantage to this disadvantage, and John found this out when I get a call from GEMA saying, put your team on standby for deployment, the swamp's on fire again. So we're calling, trying to get permission to use repeaters all around the Okefenokee. And John made a friend at one of the broadcast stations, which is a ham, and it's between 600 and 700 feet. He says, I got an antenna, let me sweep it for you. It works good. I can't give you internet, but you can put something else on it. Quickest we can get down there, we're going to put a packet digipeater on it. Right now, my friend at GEMA is working on an MOU with public broadcasting, and if we get this signed, GEMA's going to help us out with a hotspot.
Good.
So we may be back in business. We got the one with Georgia Forestry.
Yeah.
Got access now to 68 sites through GEMA.
Yeah.
So we're working on getting equipment, and although I am a kind of an AM man, I do digital too. So.
Now, what about the Georgia, the public health net since we're in the
Okay.
hospital. This hospital doesn't participate, but that
Right.
seems like a good thing.
Because we had at least either the 2 meter or the UHF module of every D-Star repeater in Georgia that was connected to the internet, listening to Reflector 30 Bravo, we call that the Georgia State Network. You already had that in place. So every Thursday morning at 8:30, they have a public health net. And so hospitals and public health offices across the state check into that net. And they have them from Brunswick, Savannah, Athens, Augusta, Atlanta area, Macon, all these places that check into that. So that's a ready-made network. The other one that is a very popular net is the Southeast Weather Net on Sunday nights at 9 p.m. And most every repeater, all the repeaters in Georgia and most of them across the Southeast link in right before 9 o'clock. And so we do a weather net, which is a good practice for a multi-state regional network, net really. And we use some software that was developed for this called D+ Report, and it resides actually on one of the repeaters or one of the gateway PCs. And it is great to be a net control and use this. Because one of the features, and I didn't answer one of the questions, anonymous kerchunkers. If you're an anonymous kerchunker, meaning that you just go around keying up repeaters and don't identify, don't get on D-Star. Don't get on Fusion because your call sign is transmitted with every transmission. Everybody sees you.
I think that's really.
So anonymous kerchunkers are not welcome. Well, they're welcome, but they'll be called out pretty quick. The advantage to that is we use that during the Southeast Weather Net. We say, all right, Alabama stations, quick key now. And what that means is they just key for half a second. And I see a list of call signs. And then I can go back and call those guys, all right, W4PL, do you have any traffic for the net? Your name and location. And I run down that list, and we do about 75 to 100 check-ins every Sunday night, and we can get through those in about 45 minutes. And I never pick up a pencil or a pen. That's another reason I don't like to do FM nets anymore. Too much writing.
John, do you or Frank, either one, have an opinion on, you look in your crystal ball, is FirstNet going to augment, compete, not ever touch D-Star?
FirstNet is all hocus pocus. No, I'm kidding. I'm kidding.
FirstNet, Skynet, then the machines take over, then they. But you say that to an AT&T engineer, and I have two friends that were on the FirstNet project, they get all excited.
Yeah.
Well, Mike's on that project.
You're AT&T as well? Well, I've known Mike for how long have we known each other? About 25 years. Mike and I worked together in the old days when it was Bell South Mobility. And I left and he stayed and became an important person.
I have my own room in.
FirstNet, does anybody know what FirstNet is? Have you had any talk about that? Well, of course you do. You work for AT&T. FirstNet was really set aside to be a data network, and it could be voice as well, for first responders. And AT&T won the opportunity to deploy FirstNet nationwide. Feds will kick in about, $6 billion, and AT&T is putting their whole LTE network up. And there was some reserve spectrum that was set aside just for FirstNet. AT&T, being wise, said, okay, we'll not only use that, what's called band 14, for the first responders only, we'll put our whole network up. Now, I love this term that was developed in FirstNet. And what the purpose of it is to give first responders priority service. So there's two terms that come out of this, and one of an extension of that is brilliant. I love it. So what FirstNet gives you is priority and preemption. So it gives first responders priority. If the defecation hits the rotary oscillator, then someday, what happened? What happened at 9/11 in New York City? The cellular network went nuts. It was overloaded, right? So if we have some type of really serious emergency, the network is going to get flooded. And even as good as it is nowadays with all the capacity that's there, it probably couldn't hold it. So what it's going to do is give priority to first responders. And let's say you still have commercial customers on there and you don't have enough space for first responders. Well, you can preempt them. And then there's this term that AT&T developed, I love it to death, called ruthless preemption. And it means exactly, am I right, Mike? And what that means is, first, if it really happens, it really hits the fan, first responders can essentially have the whole network. It's not only priority, but they will preempt anyone else. Now, if we do have that situation, I think I would prefer that the first responders have that access to a data network. Now, back to the original question, what is that going to do for D-Star or any of our digital modes? Depending on how it's ultimately configured, if you could use LTE, it might allow us to, we're like, do you know what colts and cows are? What's the other term?
Cows, boats, drones, I mean,
Yeah. A cow is a cell on wheels. A colt is a cell on light truck. One of the things that AT&T is committed to in this, and I'm not a commercial for AT&T, I promise, is that if there is a disaster, they can bring in these cell on light trucks or cell on wheels and augment the coverage. And they communicate back to the AT&T network via satellite and everything else. So what could happen, let's say we get something happening down in the swamps again, down in Okefenokee. And cellular coverage down there is either being out in the middle of nowhere, you don't have a whole lot of capacity. The cells are further apart and everything. So if they need to bring in a cell on wheels, cell on light truck, it'll provide that extra internet connectivity. Well, you could also, if the amateurs were helping with that, they could potentially connect to that and use it for the data access to the internet. And I think we will see some of that. And that's where, if you really look at, I don't want to profess to be all Aries knowing by any means, but Aries is undergoing a lot of changes right now. And as hams, we've been suddenly recognized as being of value to first respond to emergency organizations like EOCs, emergency management organizations. And so where we go in, typically that might be an Aries function because you're trained in the incident command system, you know the structure, all of that. But you may not go in as Aries. You may take off that hat and you may put on a hat called AUXCOM for auxiliary communications. You're going to hear that term a whole lot more lately or in the coming months. So the good news is amateur radio has been recognized as a valuable part of emergency communications and emergency management organizations, from all the way at the top at FEMA, all the way down to the local counties. But we're going to have to evolve, and we can't walk in our overalls and handy talking and go, "I'm here to fix all your problems, buddy."
We did that once.
Okay, and I got on to him about it, and he changed. No, you got to walk in and you say, "I'm trained in the incident command system. I know where I fit in. I can be a COM-L, COM-T, or AUXCOM operator," and they'll go, "Check in right over there. We need you." So, in the short, watch, for those of you who are in Aries, you're going to see some more changes going on with that.
John, they've already been called out. FirstNet, Rayburn County, search and, it wasn't a rescue, search recovery. And the answer was no. So the person that was in charge called another company and said, "We need some help." So a tractor trailer showed up with a tower on it, and an email got sent to the top of AT&T, and the next thing you know, they threw everything they had at them.
Yeah. Well, it's FirstNet is young.
A lot of those capabilities you're speaking about somewhat theoretically, I can tell you firsthand they work.
Yeah. Oh, they do. I know.
So what I'm really encouraging you guys to think about is somebody with an official amateur radio, whether it's Aries, AUXCOM, GEMA, somebody needs to be talking to FirstNet.
Yeah.
Similar to you just elaborated there.
Yeah. And we are. I mean, we're connected at the GEMA level, and then that's getting plugged into AT&T as well. It's going to take some time. Gosh, is it already 9 o'clock? You guys are probably ready to go home, aren't you?
You're going to present on FirstNet later this year.
And our club meeting in November, I'm going to talk on FirstNet.
Yeah. But it's a cool thing, and it's about time. So it's going to be a big help. And I think amateur radio will fit into that with, being able to provide our support in it. Any other questions?
What about the DV mumble? You ever tried that?
Oh, yeah. I bought one with my first radio, D-Star radio. A DV dongle is a way, without a radio, plug it into your computer, and using the sound card, the speaker, and microphone, you can get onto the D-Star network. You can connect to a repeater, you can connect to a reflector.
Can you make that work? I'll pick that up. So.
Yeah, the device that came after that is the DV access point. And now there's a whole bunch of different flavors. What they did, this still connects to your computer. I wish I'd have brought mine with me, but it's got a little antenna on it. So it's got a little 10 milliwatt transceiver in it.
Can I put an amp on that?
Don't even talk about that. So what happens, it untethers you from your computer. So I can walk around the room, or if I'm traveling, I can go down to the pool at the hotel with my radio, and I'm untethered, but I can still, and if I don't have a D-Star repeater locally in the area, it allows me to get on the network just like I do. Yes, yes.
Is the ID from the radio, or is it hard-coded in the dongle?
Well, the dongle has your call sign or whoever owns that, and that it's not hard-coded. You enter that into the software that loads on the laptop, and that just authorizes that dongle or DVAP to work. Then your call sign, when you transmit, is passed through to the network, so stations listening on that see your call sign.
So multiple people could go through the same dongle to access the network?
Not dongle, but DVAP.
DVAP, okay.
Yeah, because the dongle is just tied to a computer and using the sound card.
What is this?
That's a DVAP.
Okay, is that better?
DV access point. Well, it's more versatile. More versatile. And you're seeing a variety of iterations of that, the DV Mega, the Zoom Spot, the, I can't remember all the names of them now, but there are D-Star hotspots like a DV access point, but they also work with DMR and Fusion, so they're kind of multi-mode.
Maybe one final question. Has anybody in Georgia put a D-Star repeater on the X reflectors instead of just the D+?
Yeah, individually, and like anything in amateur radio, if you've got 3 people in the town, how many clubs are there? 2, right? Somebody got mad and started a second club. The original reflectors on D-Star were called D+ reflectors, and they're all REF 001 through 087, I think, right now. Well, some guys in Europe said, we don't want those US guys dominating the market. We're going to do our own. And they had DCS repeaters. Then they had XRF reflectors. So they're just different versions of the same thing. It takes some different software added on to your repeater to be able to do those. All of the ones that we did in Georgia, we only put the D+ reflectors on them because their ultimate purpose is to be able to provide emergency communications. There are some privately built D-Star repeaters around the state that are using the XRF and DCS. They're using IRC DDB to be able to do that. Any other questions? Did I bore you all to death?
No,
Well, let's thank John. That was a great
Thank you.